All right, we start off by reading our problem. Roger has 4 gallons of orange juice. He puts the same amount of juice into 5 pitchers. How many gallons of orange juice are in pitcher 1? After we read our question, after we read our problem, we always underline our question so we know what we're looking for. So how many gallons of orange juice are in 1 pitcher? We put a circle around our number in units. So we have 4 gallons of orange juice, and we have 5 pitchers. And then we put a box around our keywords that let us know if we're going to add, subtract, multiply, or divide. Most of the time, the kids already know what we're going to be doing because it's the title. But on things like ACAP and unit assessment tests, this step will be really important in figuring out what operation to use. So the same amount of juice tells us that we are looking to divide our orange juice and figure out how much orange juice will fit into 5 pitchers. So the first thing that we're going to do, since we are trying to get the same amount of juice, we're going to divide our juice. So we're going to represent our juice somehow with like boxes or circles. I like to use boxes because it's easier. So I'm going to draw 4. It's easier for me. So I'm going to draw 4 boxes. Each box represents 1 gallon of juice. And now I'm going to split each gallon of juice into 5 pitchers. So this is basically like saying if I had 4 gallons of juice in front of me, I would use 1 gallon, I would pour it into 5 pitchers until it was over. So 1, 2, 3, 4, 5. And they don't have to be the exact same size. It's just an idea to give us 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now we've split each gallon equally into fifths. So our bottom number is going to be 5. We've split it equally into fifths. And we're trying to figure out how much juice would fit into 1 pitcher. So this is like saying, okay, I'm going to take all 4 gallons of juice and I'm going to pour an equal amount. I'm going to pour an equal 1/5 into this 1 pitcher until I'm done with all 4 gallons of my juice. So pouring out that 1/5, pouring out that 1/5, that 1/5, and that 1/5. So here we have 1/5 plus 1/5 plus 1/5 plus 1 more. And when we add fractions, our denominator stays the same. If our denominator is the same, we don't touch our denominator, we only add our numerator. Our denominators are all the same, so we just add our numerators 1, 2, 3, 4. So the amount of juice that would fit into 1 pitcher is 4/5. Now, there's a trick to this. They still have to know how to show me their work somehow, but this is a good way for them to do it quickly and to know if when they show their work, if they get the right answer. If they know what is being divided or what is being split equally or shared equally, in this case, it is the juice. We are putting the same amount of juice. So the number that is being divided goes on top. And the number that we're dividing it by, we're putting it into 5 pitchers, goes on bottom. So this is what it looks like as a fraction. If we were to write this as a division problem, it would look like 4 divided by 5. So we would just take that top number, or the first number, and put it over the second number. However, that only works if they know what is being divided. If these were switched around, if it had said Roger has 5 pitchers and he wants to put 4 gallons of juice equally into each pitcher, then they would be incorrect by putting 5 divided by 4, which is why they need to know how to do it this way as well as just saying, oh, that first number goes over the second number. Because if it were flip-flopped in the word problem, they could get it wrong.